Hello everyone. Today we are going to discuss the concept packages. First of all, what is a package? Package is nothing but the container, okay? So which is consisting of classes and interface. So a package represents a directory that contains related group of classes and interface. For example, so we will write the statements like import java.io.star and then import java.language.star. Like that we will be importing. No? So here we are trying to importing classes of java.io package. Here Java is a directory name and IO is the another subdirectory within it. The star is going to represent all the classes and interfaces of that IO subdirectory. We can create our own packages called user-defined packages and extend the available packages. So here, whatever the user-defined packages we are going to import, so that packages are also can be used in our program. So we can say that package is nothing but a container which is consisting of all the classes and interfaces. Okay. So the packages has been categorized into two types. One is built-in package and second one is user-defined package. So built-in package already available in the Java language. So these packages will provide almost all necessary classes and interfaces and methods for the programmer to perform any task in the programs. For example, since we are having the extensive library of packages, a programmer need not think about any logics before doing any task. Why? Because so everything, whatever the things that are related to the logic, the interfaces and classes are already predefined in that built-in packages. So we are having the various type of built-in packages like java.line and java.util, java.awt and java.net, java.applet, java.next. If you come across with the java.lang, here lang is nothing but language. So this package got primary classes and interfaces which are essential for developing a basic Java program. So whereas coming to this java.util, so this util stands for utility. This package will be containing with the very useful classes and interfaces like stacks, linked list, and then hash tables, vectors, arrays, etc. So this main utility of this classes and interfaces will be present in this java.util. Next, coming across with the java.awt. AWT is nothing but abstract window toolkit. So this helps us to develop graphical user interfaces where so the programs with colorful screens, paintings, and images, etc. So those can be developed by making use of this package called abstract window toolkit. Next, java.net. So net stands for network over here. The client server programming can be done by making use of this package. Completely with the client server programming will be done by making use of this java.net. Next, coming with java.applet. Here, the applets are nothing but the programs which comes from a server into a client and get executed on the client machine. So on the network. So through the network, it is going to execute the program in the client. So in the client machine. Next, java.text. So this package has two important classes, date format to format date sometimes and the number format, which is useful to format the numeric values. So that is nothing but java.text. So along with these all packages, we are also having some other types of built-in packages like java.swing, javax.swing, java.sql. Likewise, we are having so many number of built-in packages. So among them, these are the mainly we are using this packages regularly. Okay. Next, coming across with the user-defined package. As I mentioned, that user-defined package is nothing but that means we can design or else we can define our own package, so which is consisting of our own classes and interfaces. Okay, so that means we are trying to create our own package, so with the selected number of classes and selected number of interfaces over here. So that is how, that means After creating the package, just like how we are making use of this built-in packages, that means we are trying to import this built-in packages. No? In the same way, we are going to import the user-defined packages also. Okay. So for defining that user defined packages, how we will be creating the package in this sense, we need to represent the keyword called package, and then we have to specify the package name. Um, so usually we used to create a class with the class name. No, in the same way, if you want to create a package in this sense, so we are using the keyword called package, and then we are specifying the package name. See here the example I have specified package and then pack. Here package and then my package. Okay, so not only this one, we can also create the multi-level packages also. That means we can able to create the sub packages also. So if you want to create the sub packages, this is just we have to differentiate it by making use of the dot. That means this is a multi-level, and subclass in this is then we need to mention it with the representations. Okay, comma representations. That's it. So this is how we are creating the general package. Okay, so package is nothing but a container which is consisting of classes and then interfaces. So we are having the built-in packages and then predefined packages. Sorry, built-in packages or the predefined packages, and also along with that one we are also create our own packages called user-defined packages. Okay, so for creating our user-defined packages, so in the last slide we have seen, no, so we have to use the package followed by the package name. So further, I have just specified the steps for creation of our package. Okay, so the first step is declare the package at the beginning of a file using the form package name. That means, however, we have defined. Okay, so pick package and then package name, and then we need to define the classes. Okay, afterwards we need to create the subdirectory under the main directory with the package. So I already told you that package is nothing but a container which is consisting of a class and interface. No. So while creating the package itself, we have to specify what are those classes and what are those interfaces that we are trying to include in that package. Okay, so for example, this is the package name. No, in this package name, whatever the classes and whatever the interfaces I want to include in this package name, that I have to specify. It is a third step. Okay, first of all, we need to represent package name, and then we have to define whatever the classes that we want to include in this package. And not only the classes, we have to mention the directories and subdirectories in that package name. Okay, then afterwards we need to store this program with the Java extension. Okay, likewise, however we are doing the else, however we are trying to run a general program, in the same way we are trying to create a package which is consisting of classes and then interfaces. Here we are ours is defining the package along with the classes and then interfaces. Okay. If you don't want to include the interfaces in the sense, then you can just include with the classes itself. It is not an issue. Okay, so we can just only include with the classes. Then finally, we are compiling the file. Okay, so for how we can compile a package in the sense, this is the compilation steps. So Java C -d file name dot Java. So Java C -d file name dot Java. Here, -d is nothing but it is a option, so which is going to tell us the Java compiler to create a separate directory. Okay, so here -d is nothing but an option which is going to specify that to create a separate directory. Okay, for that purpose, we are going to specify -d over here in the compilation process itself. Okay, so after creating a package, we want to store that package in a separate directory. So that's why we have mentioned here -d specification. Next, after doing the compilation, we are coming across with the execution. So that is Java mypack.account balance. For example, here I have taken the names of the package. Okay, so here I have specified only the syntax, but here I have represented the names of the package. That's it. That means for the execution, we want the name. No, so that's why I have represented like the name of the specifications. That means package names. So this is how we are creating our own package, which is called as a user-defined package. So coming across all with this built-in packages and user-defined packages, what is the main advantage of using this package? Okay. The very first advantage is, so the packages are very much useful to arrange the related classes and interfaces into a group. It will be maintaining a group of classes and interfaces which are related to each other. This is the first advantage. Whereas the second advantage is the packages can hide the classes and interfaces in a separate subdirectory. So what is the need to maintain it in a separate subdirectory in the sense to avoid the accidental deletion of classes and interfaces? So it will be hiding the classes and interfaces in a separate subdirectory. That is the second advantage. Whereas coming to the third advantage is whatever the classes and interfaces of a package we are having, so those will be isolated from the classes and interfaces of another package. See, we will be having the more number of packages, no? So to differentiate, the number of classes and interfaces of a single package is isolated from the another package. So it is differentiating the set of classes and interfaces from one package to another package over here. Okay, so these are the some of the advantages with the usage of package. First one is packages are useful to arrange the related class and interfaces into a group. Okay, so packages hide the classes and interfaces in a separate subdirectory to avoid the accidental deletions. And third one is each and every package individual classes and interfaces is isolated from another package classes and interfaces. Okay, so this is all about this representation. So now this is a small example. I'm going to specify you that so how we are defining the package. Okay, so in the previous slides I have just mentioned the syntax and how we are doing the compilation and how we are doing the execution. So this is how I'm going to create a package along with the classes. See, package mypack. So package is the keyword and mypack is the package name over here. Under this mypack, I'm going to create a class called balance. Okay, so in this balance, I'm going to specify the strings and that means I'm going to specify the data types. Okay, and then I'm just passing the parameters over here, string n and double b. Okay, and here I'm going to specify a method called void show. Okay, here I'm just representing a condition. If balance is less than 0, it has to print the statement. Okay, so and next I just want to specify print system.out.println and name. So which we are going to specify. Okay, so here the based on the b value, so we are going to specify the name over here. So this is the class, so which I want to use it repeatedly. Okay, so that's why I'm just placing this balance class in my package called mypack. Okay, each and every time, if whenever I want to make use of this class balance, I just make use of this package called, I can just import the package called mypack. Okay, so after importing that package, I can just directly extend, that means I can just directly make use of this class called balance. So this is how we are creating a package. Okay, so this is a very simple to create a package. Okay, just we are trying to create a package with the keyword called package, and then we are going to specify whatever the classes and interfaces we want to place in that particular package. Those and all classes we are going to mention over here. Not only a single class, we can also include the multiple classes also. Okay, so there this is the main class. So this is the continuation of this program. Okay, so here I'm just passing the values over here. Okay, so I have created another main class called account balance. Okay, and here I'm going to pass some values called current 0. Okay, So with the names and with any text and then value over here, as I have specified there, like double no, so that's why here I have mentioned the double value over here. Okay, so it is just checking with the conditions. For reading this one, it is we are making use of the for loop, and for checking the condition, here we are having the, so if, okay, if balance is less than 0, then this statement is going to get executed. For executing this one, we need to pass the values. No, here statistically only I have passed some values over here. Okay, so this is an example. Next, package importing. So now we have seen with the creation of package. No, here this is the slide which is going to represent the importing of packages. Okay, so generally after creating the package, we just make use of the keyword called import. Okay, and then we are going to represent. If you observe over here, import java.io.start. As I already told you that this Java is the main directory and IO is the subdirectory, and star is going to represent the number of classes and interfaces that it is having in this package called java.io. So in the same way, java.utility, as I mentioned that it will be consisting of stacks, array lists, and hash tables, etc. So there's those type of things is existed in this java.util. Okay. In the same way, it is for built-in packages. If you want to import the user-defined packages also, in the same way we are doing. See, package my pack one. Okay. So here I'm trying to import. Okay. In the previous example, I have defined that balance class in my pack. Oh, so if I want to make use of that balance class in the sense, then I'm just trying to import my pack. If balance is the only class in the sense, we can just represent my pack dot balance here. Okay, but if it is having the some more classes in the sense, I can just represent the star. That is nothing but multiple representation. Okay, import my pack dot star. The same way how we are defining the built-in packages, the same way we are going to represent the user-defined packages also. So this is how we are importing and creating the packages. It is very simple to make use of the built-in packages, but coming across with the user-defined packages, to import that user-defined packages, first of all, we have to create that user-defined. Then only we are intended to import that user-defined packages. Okay. Next, coming across with class path. So what is this class path in this sense? Class path is nothing but an environmental variable. Okay, so it is an environment variable that tells the Java compiler where to look for class files to import. So here we are going to specify the condition. Okay, that means location. Sorry, location. So class path is an environmental variable that tells the Java compiler where to look for class files to import. Okay, so if our package exists in subdirectory, we need to set class path. So this is the syntax for setting the class path. Definitely we want the class path. No, so for specifying that one, we have to set the class path. So for that, we have to make use of the set. Okay, then class path. Here we need to specify the location where the class path is existing, and then we need to enclose that. Okay, this percentage class path percentage means it is going to retain the already available class path as it is itself. Okay, if it is already having the available class path in the sense, it is going to retain that class path as it is only. In the cases, if you want to create a package in the sense, that means if you want to create class path instance, then we need to set class path is equal to then location. Okay. Along with that one, if you want to specify the sub packages also in the sense, this is the syntax: package name dot sub package. As I already told you that we need to differentiate the directory, that means main directory and subdirectory with a single dot. No, so here the examples: packaged. Pack1 is the main directory and pack2 is the subdirectory over here. Okay, so this is how we are specifying the main packages and sub packages. Next, accessing a package. So how we are going to access the package? First of all, what is the access specifiers in this sense? So access specifiers is going to specify the scope of the data members, class and methods. Okay, so we are having the various types of access specifiers, that is private, public, okay, and default and protected. That means, so here I have just mentioned it as no modifier. Okay, so usually we are having the four types of access specifiers: public, private, protected, and then default. Coming across with the private. So private members of the class are available within the class only. So these can be available within the class only. The scope of this private members of the class is class scope only. Okay, so that is nothing but class scope. So that's why here I have mentioned it like under private, the class members is same class only. Okay, if you observe, so out of the class is not at all possible. So that's why I have mentioned here like no. Okay, next coming across with the public. So public members of the class are available anywhere. So we can say like the scope of this public members is global scope. So it may be used within the class, outside the class, and among the other packages and different packages and within the subclasses also. So that's why it has been mentioned it as S for all the things. Okay. Next, for the protected. Protected in the sense, so protected members of the class are available within the class and then outside the class and in its subclass also. Subclass of same package. And also available to the subclasses in different packages. So that's why I have just mentioned like S for all the things, but different packages, non-subclasses is not possible in this protected. Okay. Whereas coming to this default members of the class, so these will be available within the class, outside the class, and it's subclass of the same package. It is not available outside the package. So the scope of this default members of the package is package scope only. Okay. So this is about the access specifiers. So very simple concept, that is access specifier is nothing but specifying the scope of the data members up to where we can use the data members, class and methods. So we are having the four types of specifications, that is public, private, protected and then default. So this is a simple program of specifying this usage of different access specifications. Okay, so here I have created a package same. Okay, and then I'm just specifying public class A. Okay, so private int A is equal to 1, public int B is equal to 2. Okay, protected int C is equal to 3 and int D is equal to 4. This is a default one. Okay, so within the class, I'm going to specify private int is equal to 1, public int is equal to, int B is equal to 2, protected int C is equal to 3, and int D is equal to 4. So four types of specifications I have represented. So public in the sense, it will execute, right? So private in the sense, it will get executed within the class only. If we are trying to extend this class and if you want to execute this A in the sense, it won't. Okay, even the protected also. Okay, whereas the default in the sense, it will execute. Okay, so if we try to compile this program and if you want to import this program in another thing in the sense, then it is going to execute only the public. Okay, so it is not going to execute the private. Why? Because it will be accessed. Usually, if you run this program by extending this class A in the sense, it will shows an error. Why? Because it is having the private, no. So it throws an error over here. But whenever we are trying to run this program, so excluding that error, it is going to print only the B value. Okay, so this is all about the packages. So how we are creating this packages. Okay, so usually we are having the built-in packages. Apart from the built-in, we are having the user-defined. How we are creating that user-defined, and after creating, how we are importing. Okay, so how to define the location of the class path of a package. Okay, then what are the different types of access specifications we are having.